Find the area of triangle BOD.
Given that OC equals BC, which equals to 5 units, it implies that AO equals to 10 units, which equals to radius R. R equals to BO. R is the radius of the inscribed blue quarter circle radius. From triangle AOC, let angle ACO equals beta. Thus, AO divided by OC equals 10 divided by 5, which equals tan beta. This implies that tan beta equals 2. We call it equation 1. From triangle BCD, angle BCD equals 180 degrees minus beta. Since BC equals CD, which equals to R, that equals 5 units. Using cosine rule, the square of line BD equals the product of 2, the square of R and 1 minus cosine 180 degrees minus beta. By trigonometric identity, cosine 180 degrees minus beta equals negative cosine beta. The square of line BD is called equation K. Take the square root of it, as shown on the screen. From isosceles triangle BCD, BC equals CD, which equals radius R. Thus, angle DBC equals half of beta. Consider triangle BOD. BD divided by BO equals cosine half of beta. By trigonometric identity, cosine beta equals 2 times cosine square half beta minus 1. We call it equation Q. And the sum of 1 and tan square beta equals 1 divided by cosine square beta. Substitute the value of tan beta from equation 1. Thus, the sum of 1 and tan square beta equals 5, which equals 1 divided by cosine square beta. Take the square root of the equation and we have that cosine beta equals to 1 divided by the square root of 5. We call it equation 2. Substitute into equation Q. The sum of 1 divided by the square root of 5 and 1 equals cosine square half of beta. Simplify and take the square root of the equation. We have that cosine half beta equals the sum of 1 and the square root of 5, all divided by 2 times the square root of 5. by trigonometric identity. The square of sine half beta equals 1 minus the square of cosine half beta. Substitute values and thus, the square of sine half beta equals to the square root of 5 minus 1 all divided by 2 times the square root of 5. Take the square root of the equation. It implies that substitute values and thus sine half beta equals the square root of 5 minus 1 all divided by 2 times the square root of 5. We call it equation 3. Therefore, the blue area equals to the product B, D and B, O multiply by sine half beta divided by 2, where B, O equals to 10 units and the value of sine half beta, from equation 3. Let us find the value of B, D. From equation 4. Cosine beta equals to 1 divided by the square root of 5. And from equation K, we derive that B, D equals the product of 2, the square of R and the square root of the sum of 1 and cosine beta. R equals 5 units. It is given. It implies that line B, D equals the square root of the product 50, and the sum of 1 and 1 divided by square root of 5. Substitute values in the area formula. Thus, the blue area equals the half of the product of B, D and B, O multiply by sine half beta, which equals 10 times the square root of 5 in square units. After simplification, therefore, the blue area equals 10 times the square root of 5 in square units.